My name is Katreena Mullican, as Jeremy said. I've been at AWS 4 years now. I'm just celebrating my 4-year anniversary. I am a principal solutions architect, and I support customers in the media and entertainment industry. So yeah, it's my pleasure to be with you today. And I am speaking on observability, both in AWS native tools, as well as our support of open source solutions for observability. So this is a very exciting topic. I hope you find it interesting, and I'll have some contact information. You can reach out to me afterwards, and I'm happy to follow up if you have more questions. Feel free to reach out to me on LinkedIn. All right, so here we go. This is kind of the agenda I have planned. I'm going to give an observability overview, why it's so important, why we take this so seriously, and some of the benefits of observability, the AWS native services that we have that support observability, including CloudWatch and X-Ray. And then, as I mentioned, the discussion of how we support open source tools as well. And it's very likely that you have heard of some of these open source tools, and you may already be using some of these AWS services. So if you'd like to keep it kind of conversational, so to speak, sure, if you'd like to shout out in Zoom chat, if you are using any of these currently, that would be fun to know. We're going to do a combination of some slideware and live demo. So hopefully you'll find this really enjoyable. All right. So to get us started, the term observability itself originates from the field of control theory. It basically means that you can infer the internal state of the components in a system by learning about the external signals and outputs that it's producing. The difference between monitoring and observability is that monitoring tells you whether a system is working or not, while observability tells you why the system isn't working. If you set up meaningful observability in your environment using effective tools and processes, observability can enable you to answer questions you didn't even know you should be asking. AWS gives developers and operations folks deep insights into issues, such as errors, faults, and latency problems by correlating logs, metrics, and traces across the different services. And then we offer powerful visualization and analytics abilities. So we're going to dive into a bit of that. And as you might imagine, it is a deep subject, much deeper than the time we have here together. But this is designed to showcase some of the cool things you can do with this. Hopefully, if you have a curiosity about it, to build your confidence a bit in your understanding, and encourage you to go and try some of these things on your own afterwards. All right, so we utilize monitoring to help define what good looks like for our application or our system, so that when faults or performance issues arise and things are actually starting to behave differently, that's when we use observability. And we correlate to gain insights about what's happening. And notice I said when and not if. So when issues arise, because they will, as Werner Vogels, the CTO of Amazon, famously says, everything fails all the time. We should just expect it. So we're going to look at an issue timeline. Here is kind of an overall start and end to a timeline. So when an issue is first detected, you may get something like an email notification or a phone call. And I have gotten these at 2 a.m. in my past life as a sysadmin. I know several of you have likely know where I'm coming from here. Sometimes this amounts to time getting lost just to identify and detect the issue itself. And the amount of time lost could be short, it could be longer. It's based on how your alerts work and the certain detection mechanisms that you have set up. But there is an amount of time that we need to understand is, this detect phase. The measure of the mean time it takes to detect issues in your environment is MTTD, or mean time to detect. Then comes the identification phase. So this is where you're trying to ascertain the root cause of the issue. In cases where you're dealing with a repeated known issue, you may be able to quickly jump in and fix that based on your past experience. But in most cases, this phase tends to be complicated, and it gets even more complex in a distributed system environment. The measure of the time it takes to identify your issues is the MTTI, or mean time to identify. Then you enter the fix and the verify phases, where you know the issue details and you understand what needs to be fixed. You apply the fix and verify that it's working. So these together make up the MTTRs, all of this timeline so far: the detect, the identify, the fix, the verify. It's mean time to recovery. Our area of focus primarily with this discussion of observability is to reduce the MTTD and the MTTI by quickly identifying and pinpointing issues. With this in mind, let's take a look at a typical troubleshooting workflow. As you can see, there's a different detection and identification set of actions that take place. So it is possible to correlate all of this yourself. It is possible. But if you've ever tried to do that, you know it's time consuming, it's repetitive, and it's error prone. Analysis actions will happen at different times based on what you discover in your troubleshooting journey. And you're going to need to correlate all of that data and put the information together. So there's got to be a better way, right? Yes, and you'll need a robust platform to get the job done. So you likely have seen some of these challenges. These are likely familiar to you. This would be a great point to time out that, or to point out that, like security, observability should not be an afterthought to your development or your operations, or something that you just plan to stick on there at the very end, right? That's not the case with observability. The best practice is to put this into practice early in your planning and development cycles, just like security. So we create a model for people to work with and reduce opaque corners of your application in doing that. And so you're like, okay, that sounds great. So what AWS tools are available to help? Well, we have X-Ray. So AWS X-Ray allows you to collect traces from your distributed environment through the X-Ray agent and API calls. Using powerful tools like X-Ray Analytics, you can analyze, filter, and compare trace sets to help you identify the problems. So that's one thing we offer. The other is CloudWatch. So using the CloudWatch agent, CloudWatch API calls, and other mechanisms, you can collect logs from a variety of environments on AWS or on-prem. And you can collect metrics as well. Then you use the purpose-built powerful query language that we offer on logs to analyze that log from a log group or numerous log groups. So that's CloudWatch logs. And then I mentioned metrics. The CloudWatch agent is also used to collect metrics from a variety of environments. So like I said, this agent could even be installed on-prem, and your metrics will show up in your AWS account. Using things like metric math expressions, which I'm going to go over in the demo, or other metric-related functions in our dashboards, you can analyze your metric data. And this allows you to understand the impact to your resources and service performance. The goal is to connect and correlate all of this information coming in so that you can understand your service performance, latency, and the application and business context all together at the same time. AWS observability tools are built on the strong building blocks we already have in terms of logs, metrics, and traces with CloudWatch and X-Ray. And we're continuously adding observability capabilities to solve specific use cases, and at the same time give you the ability to get a holistic view of your distributed systems. A complete picture of your health and operations requires tools that collect logs, metrics, traces, and perform that correlation I mentioned. They do analysis, they detect anomalies, help you form meaningful dashboards, alarms, and more. We broadly classify these tools under infrastructure monitoring, application monitoring, and synthetic monitoring. You're going to have the opportunity, to read more about this in some documentation, and I have some resources at the end of the presentation that I will share with you that will allow you to dive into each of this, because like I mentioned, it's a very deep subject, and we won't have time to cover all of this, but just know that all of these together make up these different monitoring capabilities within AWS. So as far as instrumentation goes, kind of check out the bottom of this graphic. The CloudWatch agent and X-Ray agent that I mentioned, by installing those, the left-hand side, right, you have the ability to store your metrics, your logs, to use X-Ray, synthetics, dashboards, all of these AWS native services on the left-hand side, including some of those insights shown, which are even more granular. That all comes from these agents. On the right-hand side, we have open telemetry, AWS distro for open telemetry in particular. And by utilizing that service and that tooling, then it opens your world into things like Prometheus and Grafana and Jaeger and Zipkin tracing and OpenSearch service and just some other open source DIY observability. So either one may be appropriate for your environment. Just know that the left-hand side is typically referred to as AWS native services. The right-hand side is open source. And I'm going to kind of cover these both. That's the goal of today's presentation. So you can just have an awareness of the difference between the two. All right, so let's jump in and take a closer look at CloudWatch, which is going to be metrics, logs, dashboards, and alarms. CloudWatch is a monitoring service for AWS resources and the applications that you run on AWS and on-prem. You can use CloudWatch to collect and track metrics and custom metrics, collect and monitor system and application log files, set alarms, and automatically react to changes in your AWS environment. At a high level, CloudWatch allows you to spot trends, centralize monitoring, troubleshoot, create metrics based on your logs, take automated actions, and have an operational status view through dashboards. Pretty cool, very multi-purpose service here. So interacting with CloudWatch, how do we do that? You can click inside the AWS Management Console, which I'm going to show you in the demo. You can go to the CLI and interact with CloudWatch through commands. There's an API that you can interact with directly from your applications and SDKs. So lots of options here to get data into and back out of CloudWatch. As far as the logs go, there are some really cool capabilities. Not only are you storing logs, but you can tail them in real time from CloudWatch. That's a relatively new feature, to be able to tail the logs. You can collect logs from EC2 instances, from your operating system, from your application that runs on EC2, even from servers on premises, VPC, things like flow logs in your virtual private cloud, AWS CloudTrail, AWS Lambda, which are some popular, Lambda is a popular serverless service, or any other AWS service. Logs have events. So the event is a combination of a timestamp and a raw event message. So here you see a very simple example of a request for a website index.php. Log streams are a sequence of those events that share the same source. So for example, a log stream may be associated with an Apache access log on a specific host, for example. So those are log streams. And then log groups define groups of the streams. So log groups share a retention, monitoring, and access control settings. Each log stream will belong to one log group. And so we'll see some of this in action. But one of the best ways to check out how some of the features of CloudWatch is to just jump in and like actually take it for a spin. So I don't know how many of you have done this. If you have, I would love for you to kind of shout out in the chat. And this will be an opportunity for me to show you a little bit about the powerful nature of this service. So I'm going to redo my share here, and you should now be seeing my web browser, right? I'm into an AWS account here. So we're going to go to the CloudWatch service. And just so you know, this account is running a sample application. It kind of has to do with pets. It's a fun topic, a fun theme. So, you know, I'm running a pet website, pet adoptions in this case, and it's just a made up scenario, but there will be some logs and metrics, etc., associated with pets in this account. The workshop I'm going to suggest to you at the end of the presentation shows you how you could set this up in your very own account if you would like to, so that you can take it for a spin. All right, so we're going to click on CloudWatch. And this should be familiar from what I just discussed in the presentation. We see on the left-hand side, logs, metrics, there's X-ray, and even some of these other things down here, such as these insights. To the careful observer, you may recognize these were in some of the previous slides. So going through something like a workshop is highly recommended because it will let you dive into each one of these. Given our time together today, I'm going to focus in just a couple of areas. So metrics is a great place to start. AWS native services report metrics by default. So even if you don't go through a lot of setup intentionally, for example, if you're using EC2 and you have a Windows or Linux, right, compute instance, say over on EC2, even without any additional steps that you take, your instance is logging to CloudWatch. And so whether or not you come here and observe it, I don't know, but I highly suggest that you check it out. So we're going to take a look here at these namespaces. So custom namespaces we'll get into in just a moment. That's something that you have the ability to create at your organization. But AWS namespaces are there by default. So the services, most every service that we offer has a namespace. For example, EC2 is our compute for virtual machines. ECS for containers. Lambda, I mentioned earlier. So S3 for object storage. You'll notice these are pre-organized for you in namespaces. So we're going to go over to EC2, and you'll notice that there are some dimensions here, and it's asking, would you like to view your EC2 compute by autoscaling group or just by instance? So we're going to go by instance, and you'll notice all sorts of available options here to search, and you can have fun. You know, I encourage you on your own to come back and have some fun with this. But I'm gonna say we're interested in CPU. So I'm typing in CPU, and it's going to highlight for me just the metrics that are associated with that. And you'll see as far as my instance IDs, I have one ending with C9, and I have a second one ending with BC. So in my case, I'm running 2. And if I want to see utilization comparatively, I could check the box for the first one and the second one. Why not? It will automatically adjust that to different colors to help me visualize. I can go over here to the graphed metrics, which will highlight for me only the ones I've selected. And at this point, I can make some choices. I can visualize based on the line, which is the default, or I could go down and, you know, look at a stacked area. I can choose the type of graph that I would like to do. I can also look at the time. Do you notice the default is 3 hours? If that's not great for me, I can simply click one of the other choices and look over a day. I can also get very granular by clicking on custom, and I can get down to minutes here. So for example, I could look over the past 15 minutes. So this is a very zoomed in version, and lots of flexibility here. If you'll notice under the custom, I can also use my local time zone if I prefer to see that instead of UTC. Some available actions that are very popular here, I can add these to a dashboard. I could share, I could download, I can view logs associated. Of course, we don't have time to go into every one of these. But for example, if I add it to a dashboard, I could create a new dashboard for us, and I can call that Meetup. And then I can go here and, create a stacked area, create my utilization, and add to the dashboard. Once it's there, I can add a whole bunch of other things. I can make this very pretty, add some text blocks, add as many graphs as I would like. But now I've got this on a dashboard, meaning I can put this up in a monitoring station. If I want to just have something to look at all day, I can also use my mouse and not only hover over key points, I can draw my own time window here and zoom in, and then I can adjust that time window throughout the day to see what's happening with my graphs. So of course, this is a very simple illustration, but you get the idea. The more associated graphs that I add to this dashboard, the more powerful this becomes to really help me understand what's happening with my application. I can add not only graphs, but check this out. I can add alarm statuses. I can add logs. So it is possible to add a log. And of course, it's going to ask you to make a selection here. But if you know for sure which logs you want from which log group, for example, I'm going to cancel out for now just because I'm not ready to show that part. But I can add logs, and you can have everything in one spot. So that's just one example of what you can do with metrics. Also, you might be asking, what happens if there's a metric I need for my application that's not here? So you'll notice when we first started checking out the metrics, I was browsing, right? And we went to EC2, and we're like, okay, it's giving us certain metrics on network, on write bytes to a disk, on things like that. You're like, well, I have my own metric, or I want to create my own metric that's a little bit fancier than this. This is just the defaults. So it is possible to use Lambda, for example, which is our serverless compute. So it is possible to define some Lambda code, and at the same time, so we're going to go ahead and go to Lambda. And at the same time, use this to inject your own metrics into CloudWatch. So I've got a function here that I wrote in Python, and it's called just a custom metric test. The name's not super important, but the function itself is a little basic, but you get the idea. So here, I'm instantiating, right, CloudWatch, a connection to CloudWatch, and I've got a type of animal and a breed of animal and the number that were adopted. So say I've got, something like this, and I want to collect this information. So I have so many tabby cats that were adopted, maybe 16 of those, for example, right? And it is possible, once you do the logic in your code, to simply put that metric data into CloudWatch, and it would look like this. I want to capture the type of pet, the breed of the pet, and the number, and I want to make a metric out of that. And notice this time I'm going to use my own namespace, not an AWS one, but I'm going to call it pet adoption, and just return a simple 200 with the words, I've published this metric. So very, very simple, but I hope that you're kind of curious what else you could do with this, right? I encourage you to experiment. I've set up a test where I inject some values. Here we've got 4 tabby cats. So I'm going to bring that up in my test and just test that. And we'll go to another test. Here I've got 6 poodles. So we'll test that. And I've got 2 bulldogs. And if you're curious what these tests look like, this is a built-in capability with Lambda. All of this is I'm sending my function some values. So I'm saying the type is canine, the breed is bulldog, and the number adopted was 2. So you can customize this test however you like. And then by clicking on the test button, I forced my function to run. Now remember, I asked for a specific namespace. So I'm going to go to CloudWatch. And we're going to look to see under metrics if that namespace was created. So here's all my custom namespaces for my account. And here's pet adoption. So we see it in the list. And it tells me, oh, I know things in here. I have metrics in here based on breed and type of animal. Cool. So it's got bulldog, canine, poodle, and tabby cat. So if I select all of those and say that I would like to graph these, you'll notice there's nothing here. So remember, CloudWatch takes a moment for these metrics to register. And also, this is brand new. So I'm not going to have this from the previous day, right? I just did this 30 seconds ago. So it's not going to exist. My period right here is 5 minutes. It's not going to have existed for 5 minutes. But what we can do is change that to be, for example, 30 seconds. And over the past 30 seconds, it should have some information. So this is up to you to make these adjustments. If you notice, over 30 seconds, we do have these dots. See over here on the right-hand side. So there is data. Also notice at the top graph, it's set to 3 hours. So we want to customize that, and we want to look just for the past couple of minutes. Here are my values. So at this moment, I had, tabby cats, canines, and poodles. So it's a very, very simple example. But the point is, I just made my own metric based on my application, and I was still able to use CloudWatch. At this point, of course, I could add it to my dashboard. I could share this out. There's a lot of other really neat things you can do here. So don't be limited by the built-ins. Always think outside the box, and know that you can customize this. I want to show one other really exciting example, because if you know my history, I'm a math nerd. So, so I want to show off some metric math. So what we're going to do is clear this off and clear this entry here. And we're going to go back to metrics. We're no longer going to look at the custom pet adoption. We're going to go to all metrics. So I'm going to shrink the custom namespaces and go back to AWS. In my sample app, I am running a load balancer, so I'll be able to see those metrics under the application elastic load balancer. So let's go there. I want to focus on the per load balancer metrics, and this is totally up to you. You have to really take this for a spin to understand what lives under each of these categories. But for my needs, I'm good with the per application metrics. All right, so the one I would like to look at is the request count. How many requests are coming into my load balancer? So I'm going to check that box, and I'm going to go to the graphed metrics. So again, this is a nice view because it isolates just the selection that I made. Now let's do some math. So I'm going to grab the add math pull down here, and this is full of cool stuff I would love for you to check out. There's common functions like converting to a percent, converting bytes to megabytes or gigabytes, or seconds to minutes. Those are common, but look at all the stuff you can do. You can sort, you can do conditionals with ands and ors and greater thans and all sorts of fun. You can do SQL queries and this, but we're going to start with an empty math expression. So we're going to roll our own here. And let me know if there's anyone who thinks they understand what this does. This isn't really math. This is just logic. So I'm going to paste this in here. All right, so let's walk through it. So in this scenario, I have a metric, and let's say my application is super important while my employees are in the office. Okay, so we're talking, I care most about this Monday through Friday between 8 and 5. Or between 9 and 5, let's say, for work hours. If that is the most important thing to me, I may not want to see noise from Saturday and Sunday and midnight. I may not care about the level of requests I'm getting during those times. I want to isolate and just look at certain times of the day. So what this says is if the day of M1, which is my metric, so if the day is less than 6, so this would be Monday through Friday, and the hour of that metric is greater than or equal to 9, and less than 17, so 9 to 5, then graph the metric. And if we apply this, we see some differences. So let me get this out of 5 minutes. First of all, it's stuck on my 5 minutes. Let me zoom way out. I want to see like a day. Oh, well, maybe not quite so far out. I want to see a few hours at least. Okay. So you see, normally it's graphing both things for me. It's graphing my math on the top and the regular request count on the bottom. So one is orange and one is blue. I'm controlling it with these checkboxes. So all of the data is orange. That's a lot of stuff. Let me change this period here to be a little bit bigger. So let me go over maybe, let's say an hour. So this is what the request count looks like for the past hour, right? This is what it looks like for the past day. And then this is the math on top of it is going to be blue. So let's set this one back to days so we can kind of see. So let me get this going here. 1 day. And you can see how it makes a difference on the period I'm selecting here and the overall graph at the top. It takes a little bit of practice, but the top is just the hours that I want, and the bottom is all of the hours. So basically, you can use metric math to logically show, right, that I only care about certain hours of the day. It's just one use of math. I think it's cool. You are welcome to dive into that, change those periods around, and have some fun with that. Awesome. The very last thing I want to show before I go into the open source is a quick log demo. We'll see if I have time, but I'm going to go into one of those log groups that we talked about. And I just want to let you know, this is where you can go inside of a log group, pick out the group that you're interested in, such as your application. From my PowerPoint, remember now we have streams. So the group contains streams. These streams are full of information. Every one of these can be expanded. This is where you can go to help troubleshoot. And of course, there's filters and all sorts of things you can do here with these logs. You can even take text. If you want to know how many times you failed to scrape Prometheus in this case, you could take this text and convert it to a metric. So you can actually have CloudWatch graph the number of times this message shows up in your log. And so that is done by going up to the top of your, this is a long stream, going up to the top of your log group, which is this application, and then going into creating the metric. So the metric filters. And so we don't have time to do all of it, but just know it's possible. Please reach out to me if you have questions, and I will happily point you to documentation. But this is where you can literally filter, tell AWS to filter on that key phrase and graph it as a metric. Really, really neat. And so now I want to kind of go over X-ray, which is one of the ways that we can do some traces. And so let me find my Zoom window and get that going here. Hold on 1 second. Stop the share, and I'm going to share back. Okay, so now you see my PowerPoint. X-ray is another building block here, because remember, CloudWatch was for logs and metrics, and X-ray is for traces. So it enables us to trace distributed applications, a request all the way from when it leaves, when it comes into your workflow, all the way to the end. And things may be going swimmingly, there's no issues, but if there's any hiccup in between, X-ray will visually show you that. And also provide much more information into the logs and the metrics and exactly what the root cause of that interruption to the path was. So for X-ray instrumentation, we have two choices. There's an SDK that you can use in your application. It's available for Java, .NET, all those things that you see there, Python, Go, Node.js, or we have OpenTelemetry, which we're going to talk about in just a second. So either way, you have the ability to get your information, your behavioral information into X-ray. So I wanted to highlight for you what that is going to look like. So just real quick, in my application, I do have X-Ray set up. Guess what? You don't even have to leave CloudWatch. It used to be that you had to navigate separately. Now you just simply scroll down. You can see a service map from X-Ray, and you can also, on the left-hand side, see traces. So I'm going to focus just real quick on a couple of traces. You'll see I've got a couple of errors. That's interesting. And I've got some that are okay. So by clicking on a trace ID, you'll be able to see a client come into the site. You'll be able to see exactly what the response code was, how long it took, and you'll be able to understand if there is an issue. And literally, this will turn green or red for you based on a response code that comes back. So here we've got 200. Which is A-okay, so congratulations, that's fantastic. If we look at another one, I don't know if I can get a separate, let's just see if I can grab one here. Those all kind of look the same. I was hoping to get something slightly different, but that they all may be, yeah, they're all pretty similar. But this is where you go. This is where you see the traces. Also, if there's something going on here, so this one has an error, meaning, something was not happy. So if we scroll down, we'll see, okay, an error came back. We're able to click on that in X-Ray, and we're able to go over here and examine if there's any exceptions. You could provide that back to someone who's helping you with your logs, for example, and you can also view logs in CloudWatch. So this gets a lot more complicated, as you can imagine, for a more complex application, but that in essence, this is where you go. So whether you're looking at an error message or a trace, there's different places that you can go to see that. And I can try to grab another error and just see if it looks any different for us. But it looks like most of these are kind of sort of the same. Let's try one more. I was hoping to grab one that had some more. Nope. Okay. So those are pretty generic, but you get the idea. This is where I'm at. I'm in CloudWatch and under X-Ray. All right, so that's the tracing component. Remember, observability is 3 things: metrics, logs, and traces. All right, awesome. So we're going to finish up now with the conversation about the open source. So this is super exciting. AWS does support the open source, and this includes things like OpenTelemetry. The first one I want to start with, though, is Prometheus. So this is a very popular open source monitoring and alerting solution optimized for container environments. If you run containers, if you've heard of containers, then you likely are familiar with Prometheus. It's well known because it has simple metric collection methodology. The metrics are just published as HTTP endpoints, and they're collected, or what we call scraped, at regular intervals. Then they're stored in a time series database. So great. A lot of people run this on their own. A lot of people do self-managed Prometheus, but our customers came to AWS and said, it would be awesome if we offered this as a managed service. Mostly because if you DIY and do it yourself, Prometheus project isn't really designed to deal with long-term and highly available storage. And a lot of customers require that. It's great to analyze this in real time, but what happens when for compliance or something else, I need to store these. So introducing AWS Managed Service for Prometheus, or AMP. This is a Prometheus compatible service that allows you to monitor your containers and your infrastructure at scale. So because it's a managed service, you benefit from scalability and high availability that we worry about at AWS, and you don't have to touch the underlying infrastructure. Another popular open source service is Grafana. A lot of folks run Grafana on their own, but there's upkeep with this, right? If it needs to scale out because you're out of space, you need to put some patches on there. You need to, take care and feeding of your Grafana. That can be a chore, depending on your, use case. So we came up with Amazon Managed Grafana. Again, a fully managed solution. This allows you to query, visualize, and alert on your metrics, which can be collected by Prometheus, or a wide array of other data sources. So you can see CloudWatch here. You can see OpenSearch, Graphite, Jaeger, InfluxDB, wherever your metrics are coming from. If they're coming from, there's a list, but a wide variety of places. They can be ingested into Grafana. So with this, you can analyze metrics, logs, and traces without having to do all that heavy lifting of scaling and, care and feeding of your own infrastructure. So let's walk through real quick an illustration of how AMP, so managed Prometheus and managed Grafana, AMG, can be used together. So here on the left-hand side, you see a container environment. It just happens to be EKS in AWS, but it doesn't have to be. But this is showing Prometheus running there. So understand that AMP, the managed service for Prometheus, does not scrape operational metrics from workloads in ECS or Kubernetes. It requires you to deploy and manage standard Prometheus. So we show a Prometheus server on the left-hand side that we run in our containerized environment. So that's required. But then AMP does include a remote write compatible API. So it can ingest metrics from the Prometheus libraries, your existing Prometheus server, from OpenTelemetry. That ingestion's happening to that purple circle on the left. And then Prometheus server uses a VPC endpoint to write that data into the AMP workspace, which then utilizes S3 to store your long-term metrics. So you see the communication happening here with AMP in the middle, ingesting from Prometheus, writing down to that S3 bucket. And of course, then we have Grafana over on the right. So once your metrics are in AMP, Grafana is able to showcase them and to show them, and then you can use Grafana native tools and abilities to do your analysis and your dashboarding. So it is possible to use all of this together, and it's a very common combination that we see customers doing. This helps you to scale. So OpenTelemetry is another hugely popular option for your observability needs. It is a framework. It uses cloud native software from the CNCF project. So it's a standardized set of APIs, SDKs, and agents that allow developers to instrument their application once. It is awesome. You instrument one time, and then you define your targets. And you can then take your collected metrics with OpenTelemetry, your traces, for example, and you can put them out to a variety of places. So things like Datadog, Splunk, New Relic, these are all accepting OpenTelemetry, many others as well. So if your tooling that you're using accepts OpenTelemetry, then this is something I highly recommend you look at, because otherwise you have to have a separate agent, which is a lot of things to maintain for versioning and patching. You'd have to maintain a separate agent to talk to all of these different things, a Splunk agent, a Datadog agent, a New Relic agent. So OpenTelemetry is one and done. It's definitely worth exploring. And we have our very own distribution of it called ADOT. So there are multiple distributions out there in the world for OTel. This is the one from AWS. So this is a secure production ready AWS supported distribution. So with this, if you have AWS enterprise support support in your account, for example, you can open cases and get help with this, which is, a big plus for a lot of places. With this, it collects metadata from your AWS resources and your managed services, so you can correlate your performance data with underlying infrastructure data and help reduce that mean time to resolution that we discussed earlier. So if you're searching for a distribution for OTel, I highly encourage you, if you have AWS resources already running, that you consider the AWS distro ADOT. Here are some of the use cases. So if you just want to standardize your production-ready open source APIs, you can do that. If you want to instrument your code once, which is a huge plus, that very well may be your use case. or if you just want to take advantage of a wide set of languages and auto instrumentation agents supported by OpenTelemetry. So I have some resources to share with you, to take with you, and I will put these into the Zoom chat. But these are awesome. You can set up the workshop that I had running in my account. You can set it up in your very own account, which means you can go at your own pace and dive into each and every clickable thing in CloudWatch at your own pace. So just keep in mind, there is typically a cost associated with some of that. So typically you'll set this up, use it for a day or two and then clean it up. And of course, the workshop includes instructions to do that. So you don't want, to have unintended, charges on your account. So just keep in mind, if you do some of these workshops on your own, please clean up. There's also an observability best practice guide, which covers what I had in this presentation and so much more. It's a great read. So I highly suggest that. Skill Builder is an awesome resource because it has self-access, to video resources. So, well, I say video, I mean digital. It's more like a digital class that you can go through free of charge, and you just sign up with any email address. So Skill Builder is amazing. Of course, there are paid options as well, but there's hundreds of services that you can learn more about for free on Skill Builder. So I highly recommend you check that out. And of course, if you want to surround yourself with AWS-minded people speaking about CloudWatch, observability, OpenTelemetry, and everything else, you will find them assembled in Las Vegas between November 27th and December 1 at what we call reInvent. And it is a blast. If there's any way, you might want to consider working with your organization to send you to that. I highly recommend it. It is coming up every year. It's the same time of year, the week immediately following Thanksgiving. So I'm going to paste those things now into the chat, those links so that you can have them. And you should see them now. I thank you very much and encourage you to try some of what I showed. I hope you're inspired and curious and want to, try those things out, and I encourage you to find me on LinkedIn. I would be more than happy to hear about your journey and give you some awesome advice.